Welcome, everybody. We're going to pick up where we left off in Unit 2. If you remember, last time we finished Unit 2.2, Part C, Parameters and Results. So we're moving into Part D today, which is Making Decisions. And I'm bringing up my student zip, sample files or playgrounds or whatever here in my Finder. And you can see that I'm kind of in the outline mode, so I can find my playgrounds real easily. So I'm going to go ahead and open up the Making Decisions playground here. And if it's the first time you're opening it, you will get a message saying trust and open. And we do want to do that. So this is what this one looked like. I'll give you a moment to get up and running on this, and we'll get rolling. All right, so when I teach traditional programming classes, and when I say traditional, I think about, regular programming like Python or Java or C#. Those are kind of the three primary languages that we teach here at Gateway. And we have this little mantra that we do about programming and the logical structures we use to do programming. And there's basically three, arguably more than that, but the three basic ones for doing programming are sequence, which is a step-by-step set of instructions. The second primary one is selection or decision-making, which is where we are today. And then there's a third major structure, which is repetition or looping. In truth, there's others. There's things like recursion, for example, and other little things that we do. But basically, it's thought that with the combination of step-by-step selection and repetition, that you can solve just about any logical programming problem with those structures. So really what we've done so far in this class is we have not done anything really too deep. We have not reached a point in the program where we ask a question, and depending on what the answer to that is, we diverge our path. And one of my classic examples I always do in the classroom is, maybe your decision for tonight is, if I have $20 or more, I'm going to order pizza delivered. If total cash in pocket is less than 20, then actually I might make mac and cheese, right? Because I don't have enough money to order out, and these are decisions that you make, and they determine which path you're going to take. And that's really kind of the grand goal here in this particular subunit in Unit 2. All right, so a code segment refers to a collection of program statements that are part of a program. All of the code segments you've written so far have run in playgrounds and run from the first line to the last in order. So this is the sequence thing that I'm talking about. And my comparison in traditional programming always is I use recipes as kind of an example where the ingredients become the data, and then the process of making the food are the steps. And most recipes, if you think about it, are like really very step-by-step, so like you preheat the oven, you mix your ingredients, you put them in the oven, cook them for a while, take them out, cool them down, serve and enjoy, right? But that's a sequence of steps. There's no alternative path to it. It's just a preset standard of steps. So it says no matter what you give your code to work on, it does the same things with it because it's following a process that's predetermined. Consider the string interpolations you learned about. You had to perform a calculation and show the result in a string, something like this. So we learned how to apply a number to a constant, right? And then another one that's a string, another one that's a string, and then the string interpolation is where we can kind of inject that, content directly into a string using this backslash and the parentheses, right? That's called string interpolation. And interestingly, we did a couple of things here, right? So it says like your video is blank seconds long, and we're just forcing a number in there. But what if there's actually variations to this. I think, and that's what the author is getting to. Said, if the answer was 3, then this works fine, right? Because you've preset video length to 3. So the output would then be your video is 3 seconds long. If I blink, I'd miss it, right? And that's not what, this is not happening automatically here is kind of the grand point. The number is hard coded, it's predetermined. The short reaction that we're putting back up on the screen is predetermined. And notice that the reasonable length reaction never gets executed basically because we don't include it. And the only way we can really include it is to manually insert it in a predetermined fashion. And that's what they're kind of getting to. So for example, in this scenario where the 3 seconds was preset, what if, it's this many seconds long, that message doesn't apply then, and for us to change it, we'd have to manually change the code to accommodate the change in the value. Doesn't make any sense. That's not how programmers want to work. The programmers want to work smarter, but we want to allow our code to make the decision for us and then dynamically change the message, right? That's kind of the grand goal here. All right. So now they give another example here, and they talk about this concept of true false, right? And in programming, we tend to refer to true false constructs as Boolean values, right? We haven't really talked about that very deeply. But it says in the game 20 questions, you can identify anything in the universe just by asking questions with a yes or no answer. Questions with simple answers can be very powerful. So it says you can write code that can be thought of as a question, and Swift will tell you if the answer is true or false. You can see the results in the sidebar just like when you entered the calculations. So the reality is if you look at how true and false are represented here in the coding area, they're color coded like a keyword, like let is. Like let is a keyword. True and false are also keywords. And yes, you can actually kind of just brute force type the word true or false, and Swift will pick it up and put the value true and false, right? Yes and no, 1 and 0, but positive or negative, but true and false are special constructs in most programming languages. You can also take those special values and actually assign them to constants or variables, right? So like here we're saying let yes equals true, and then when you just output yes, that's obviously true. Let no equal false, and then no is false, right? That's kind of the point there. These Boolean values, by the way, if you're wondering where that name came from, there was a guy in the 19th century named George Boole, who was a 19th century mathematician who basically was looking for, well, it's one or the other, which is it? He was looking for that kind of a response, like where you ask somebody, it's like, did you do your homework or not? Well, I was kind of busy, and okay, so you didn't do your homework. Just answer no, is kind of the point. For whatever reason, when we are working with true false values in programming languages, they actually do have their own data type, right? And this is typically called Boolean. In Swift, we use the BOOL as the keyword to talk about Boolean values that are true and false. All right. Here's kind of the funny thing. They have this line of code, and they say let perhaps equal maybe, right? So here's like the not true false thing. No, a maybe is not a keyword. It's not a special value. And in programming, we want one or the other. It's either on or off, true or false, yes or no. There is no maybe. Like Yoda said, there's only do, right? If you guys ever remember that from Star Wars, or I forget how the quote goes, there's no in between. You're either doing it or you're not doing it. So pick one, right? And maybe is not appropriate. So I'm going to comment that back out to get rid of the error. Now, we could fix that, of course, by changing that to true or false, and then it would render just fine. let's move on to the next page. Another thing is that, you know, we start to think about true and false in a special kind of way in programming, because often when we're making a decision, it is based on whether something is true or false and not anywhere in between. So like going back to the example of the pizza, right? If I know that it costs me $20 or more to get a pizza delivered to the house, I mean, $20 as a threshold is pretty wise. So if I look in my pocket and I go, all right, I got $19, that's just not going to be enough. So do I have 20? False, right? So I'm not ordering pizza, I'm making mac and cheese. I have $20.01. Do I have at least 20? True, right? And then you execute that path. So they're saying here that true and false are special values, and without typing in bools directly, okay, so, and generally it's not like, you know, sometimes you do hard code true and false values for certain reasons, but you want to ask a question in code like my pizza money question. The result of the question being answered is true or false. And so what we do is we put together what we call comparison statements, or statements where you are comparing values or constructs or whatever, with hoping to get a result of true or false when you look at it. So what they're saying here is that comparison statements say something, and Swift will say that if something is true or false, then it has basically three parts. And look at how they kind of phrase this. I think it's kind of interesting. They say this, number one, this has a relationship to that. Okay. Okay. So what could that be? You know, maybe it's the money, maybe it's the pizza or the mac and cheese, right? They're trying to go with that example. It says part 1 and 3 are values, and the numbers and strings you've already been working with. So part 2 is something new for us. Like if you've done this in programming, you'll be familiar with this. And basically we're looking at comparison operators. Now, it's really kind of interesting because we've, as you know, human beings, when we learn math as children, we are taught plus, minus, multiply, divide, and the symbols that go with, and then ultimately you learn that equal sign. And then we come to programming, you learn, wait a second, equal signs are not equal signs, they're assignment statements, right? So they're assigning a value. So how do I check to see if something is equivalent then? And then the answer to that becomes the double equal sign. You put two equal signs together, and you put one value on one side, one value on the other. And what it really is a question to test to see if these are truly equivalent. And that's why when I say 1 equal 2, or is 1 equivalent to 2, the answer is false, right? Whereas if I change the 1 here to a 2, are these equivalent? Then the answer becomes 2. All right, so that's really what that's doing. And you can see they call it here the equality operator. And I always like use the terminology in my head when I think about the double equal sign, that it is equivalency. You know, so is this equivalent to that? And you know, then we're looking for a result. So this doesn't like do any math. So like if I put an equation on the other side, it would evaluate the equation, but then check to see if it's equal to the other portion. So if I did 2 plus 1, is that equivalent to 3? Yes, it is. But is 2 plus 2 equivalent to 3? And that's false, right? So it's not really doing math here, but math is allowed to happen on one side or the other. So whatever the math is isn't changing the value on the other side. That's still a comparison operator. We're still comparing the left side to the right side. Interestingly, depending on the language that you're working in, most programming languages do use this convention of a double equal sign, by the way, to test equivalency. In some languages, we also have a triple equal sign. And I think it's kind of interesting to note that, because a triple equal sign would also denote that the values are equivalent, but also of the exact same data type and structure, which is a little bit deeper ask, right? But I don't know if we see that in Swift or not. I would suspect that that is available in Objective-C underneath, so probably is available. We'll see. All right. It says the following slightly more complicated example is true, and I just kind of demonstrated this, right? Where we can do the math, but we're not really assigning the value, we're still comparing, right? So if you are going to do math, what they do sometimes recommend, right? And very common in programming, because maybe those numbers that you're working with will change. So like one week, I have $19 in my pocket. The following week, I got $21 in my pocket, right? And I don't know why, maybe I bought a soda one week and the other week I didn't. But what they're saying here is that it sometimes makes sense to take your math in advance, do the math, store it in a variable or a constant, and then check the variables or constants to see if they're equivalent. So that's what they're doing here. So first, we just set one value to 100, hard-coded. The other one is doing some math and then saving it in a constant. Of course, we know that's 100 also, while this one is 90. So, I mean, we can look at this and probably just have said, oh, I don't understand why we're doing this, so I know what the answer is, right? But what if it's a much more complicated number? We might not know the answer. Or what if instead of numbers in those positions, those might be variables or constants with information from somewhere else, or even worse, might be a spot where a user could input information, right? It could be all those things. So they are demonstrating here, though, that you can take values that are stored in variables or constants and then do the comparison and get the results. And you can see the output here. All right, so here they're asking us to do a little bit of an experiment. So I'm going to like type in a little code here, because so far they've been working with numbers, and I think those are pretty tangible, right? Like numbers are pretty easy to kind of wrap your head around. But what if we have something like this? I'm going to say message 1 equals, we want to compare strings here is what they're asking. All right, so I have one that's hello, right? And then let's do another one that's message 2, and I'm going to be really kind of goofy about this and put in something I know doesn't equate, right? And then let's do a third one. Let's do message 3, and this time let's do hello, but not with a capital H. All right. Now, the next thing I'm going to type in here is to test, and all I'm going to say is message 1 equal message 2. And notice how I'm even saying it. I'm like putting a question mark in it. Really, that's what's happening here. I'm saying, is message 1 equivalent to message 2? And it gave me a false. That makes sense. Now, is message 1 that says hello equivalent to message 3, which also says hello, but with a lowercase h? Are those equivalent? No, they're not. And this is kind of telling of strings, that they would have to be identical. Let's see if it updates here. True. What if I add a space to the end? Does that count? It does. And so that's kind of interesting about strings. So with strings, we are looking for precision in case and exact characters, right? So this, does some interesting little things here. So you can experiment with that all you want. But I think you get the point, right? So like we can compare strings as well as we can compare numbers. And I think that's pretty helpful to know. All right, so they're using the equal sign, right? And I think we understand that we're checking to see if things are equivalent, but sometimes that's not what we're looking for, right? I don't need my cash in pocket to be exactly $20 to order pizza. I need it to be at least $20 to order pizza because I've ordered pizza in the past, and then I know the pizza costs, 15, and there's tax and the delivery charge, and you want to give the delivery person $1 or $2, right, as a tip. So you really need $20 to order that pizza from experience. But it could be more than $20, right? So I could have 25 or 30 or 100 or 1,000 or whatever. And then we start to use the other mathematical operators, the same ones that you learned in math class, which are greater than or less than. So for example, Is 1 less than 2? Yes, totally true. Is 2 less than 2? Of course not, right? They're the same number. Is 3 less than 2? And you can see how the responses are going here. And you can kind of, keep going on this. You also have greater than, or more than in this case. Is 1 greater than 2? False. Is 2 greater than 2? Of course not, right? And is 3 greater than true? Yes, that one certainly is. So you can see the results. These are common types of comparisons also, and those number positions could easily be replaced with constant or variable names if necessary. All right, there's a few comparisons that do use multiple characters to do the comparison. So like the equal is one of those, right? But we also have a way to denote in programming that something is not equal. This is kind of a universal truth in programming too, that the exclamation sign in front of an equal sign generally means not equal, right? So when we say, is 1 not equal to true, or to 2, and which is true, right? Sorry, I fumbled my words there. Is 2 not equal to 2? Well, that's false. It is equal to 2, right? And then is 2 not equal to 1? That's true. So sometimes you have logical questions that need to be, we're looking for the negation of that, So, all right. Then there's the less than and equal to or greater than and equal to, and you maybe have seen this before. These are typical mathematical concepts also. In regular math, though, when we do greater than or equal to, we usually kind of do this kind of thing, right? So we say greater than or equal to in mathematics, which here we don't have that character on the keyboard, so they string them together basically to get that thing. So they say less than or equal to or greater than or equal to. I have had students ask, can you put the equal sign in front of the exclamation or the equal sign in front of the greater than or less than? And the answer is no. It has to be in this order. And the key or the clue to it is in how you say it, right? So not equal, or less than or equal, or greater than or equal. Equal always is the last character. But you can walk through these comparisons here and prove to yourself that they do work. Is 2 less than or equal to true? 2, of course it is, right? And that's kind of the neat thing about the equal sign. 1 is less than or equal to 2, 3 is not less than or equal to 2, and you can follow through the rest of those. Now, I think this is kind of a fascinating little concept, if you've never done this before in a program, but there are ways, right? So like, all right, so with numbers, it makes sense if something is less than or equal to, but does that apply to letters? Here's the really weird thing. It totally does. Because when we look at, the ASCII table of characters, and I'm just going to do this in an image format here, and we'll see if we can find any chart will do, really, when you look at this stuff. But when you create this character, so the ASCII column is the character from the keyboard. And I want you to notice that when you look at like the capital letter A, it's got a numeric value of 65 in base 10 numbers. This is the binary number, the base 8 number, the base 16 number. But for us, we think of it as A, right? The small letter A also has numeric values attached to it, but here's what's kind of weird. If I ask the question, is capital A less than lowercase a, what should the answer be? True, right? And here's how they determine it. They determine it with these numbers. That's kind of weird. So I'm going to kind of just prove that here and just say, is capital A less than lowercase a? And I'm making a mistake already because it's got to be in quotes, right? Like that. right? So we proved exactly what that chart said. And I think that's pretty interesting. So this actually can apply to strings. So what I think is really kind of interesting is they have a little thing here that says, note, a helpful way to remember what greater than or less than is to think of the symbol as a greedy mouth, right? Always eating the bigger value. Okay, I don't think of it that way. I just kind of remember, and really it's like the pointy side is pointing to the smaller value. It doesn't matter which direction it's going. That's the way I think of it. So hopefully you think of it. Now we did a little comparison with letters there. But you can feel free to experiment. I think the examples that are provided here are absolutely fine. And I think they do aid in the understanding. All right, then we move on to the conditionals. And this is where we start to take this true-false knowledge and put it to work, basically. All right, so it says you've learned about true-false. You've seen how to write comparison statements, right? So we figured that part out. The final part of the puzzle is how to make your code do different things depending on these results. So at the start of the playground, you read about the reactions to the length of the video. Now it's time to implement that in code. So what you want to happen is this. If the duration is shorter than 5, say it is way too short. If the duration is greater than or equal to 5, say it was very nice. Okay, so very simple little situation here. The code is similar how you'd write it in prose. So let's take a look at what they've written here. They say, let video length equal 5. So that's being preset. Maybe in an ideal world, if we're writing a program, we would actually probe for that value or ask for that value, right? Then we ask the question, and we use the keyword if. If the video length is less than 5, notice the curly brackets here, we will have a string that says, if I blinked, I'd miss it, right? Which is their way of saying it's way too short, right? Then we have a separate if statement saying if the video length is greater than or equal to 5, that's lovely. Now, with the value set the way it is, will this one ever happen? The first one, and the answer is no, because 5 is hard-coded. Right? So video length of 5 is not less than 5. That's false. So because it's false, the code inside the curly brackets never executes. So here's what happens in an if statement. If the logical test, right, or the condition is true, then the code immediately following inside the curly brackets will execute. In this case, it's false, so it never happens. With the second one, is 5 greater than or equal to 5? Of course it is, it's equal to 5. So that registers as true, which then triggers the code inside the curly brackets. That's lovely. That's why this one has an output and this one does not. This one evaluated to false, the first one, and so it did not execute the code. If you want to test to see if it actually evaluates to false, you can just copy and paste it out, and you can see it evaluates to false. Right? So that's a pretty good takeaway there. All right, so if you didn't figure this out yet, this is called an if statement, right? So this is like a very basic programming construct, but like I said before, one of the 3 important ways of solving logical problems in programming. And so they're giving you a little example of how it works. So they say if ... some code that could be true or false is true, run the code inside the braces. Otherwise, skip it, right? And we saw that example here that this evaluated to false, so the stuff inside the curly brackets did not execute. Now they're asking us to experiment a little bit, and they're saying change the value of video length and see how the new value affects the code that is run. All right, let's try that. So here we're presetting it to 5. What if I change that to 4? Now what'll happen is now the first if statement, because video length is less than 5, will trigger because that's true now. The other one will not because we're not greater than or equal to 5. And so the first statement triggers, second one does not. What if I don't set it to 5? What if I set it to 6? All right. Well, still the second one applies because it's greater than. So this comes with a little bit of practice, like how these will evaluate. And sometimes you have to do a little preconception as to what values you're expecting and what kind of effects you want to get. It also helps, and this is, programmer's wisdom here. Sometimes when you ask the logical question, you can ask it in a positive sense, or you can ask it in a anti sense. It's kind of like using a double negative or something like, do you not have $20 or do you have $20? If you catch my meaning, right? So like it's all in the expression. So the other experiment that they have posed here, it says, what happens if you change the comparison in the first example so it complains about videos shorter than 10 seconds and then set the video length to 8? All right. So they're saying change this to 10. They didn't say anything about changing the other one. I don't know if you caught that part, right? And then change the value that we're feeding in to 8. So we do this. All right. Now, interestingly, it's true for both statements now. They're not exclusionary, basically. So it is possible to trigger both statements to run. It's all on the values and how the statements are set up. All right. Now what they want to do is throw in the next logical part of this, because, going back to the pizza example, if I have $20 or more, I'm going to order pizza. And then what comes next? So here's where human logic kicks in. Else, I'm making mac and cheese, right? And, their example here, so they're going back to the video length example, we've preset it to 5. Here we're looking to see if it's greater than or equal to 5. This will trigger this. So this one's true, so it will. If the video length is less than 5, which it's not, then this won't. But maybe that's not really what we're trying to accomplish here, right? So the pizza example is a perfect one to put in. Really what we just need to test is the first thing. So if it's really super short, let's give them a message saying, hey, it's super short, right? Else, you can just say that's lovely, right? And in this case, because the number is 5, which is not less than 5, you'll get that's lovely. If this is changed to 6, however, the first part will trigger. Nope, because that's not less than either. 4 is less than. So now 4 will trigger the first part of the statement, and then otherwise it would operate. So this combination where you really, this example that I'm using, the pizza example, is really kind of a fork in the road. Maybe a better example of like the straight up if statements would be like, if I have any money, I might consider ordering food, even if it's like, a couple bucks. If I don't, I'm not going to order food. I'm making something at home, right? So that would be like if statements. When we do an else, though, the process, and they have it listed here, it says if some code that could be true or false is true, then run the code inside the braces. Else, if that isn't true, is what that's saying, run the code inside the second set of braces. So you're set up for both scenarios. So if you're triggering one true, great. If you're not triggering the other, well, then the alternate code will run. All right, so I think we kind of already did this. Change the value of video length again and confirm that the results, all right, so we did that already. And it says change the values that video length is compared to by changing all the 5 values to other values. Try to make both messages from the top if statements appear at the same time. And so what they're asking us to do here is kind of just play with these and adjust them. And you know what? This is something you can kind of figure out on your own. But really play with the values and see how they're functioning is kind of the grand point. Now, if I was to put this at 10, that's not going to trigger. So what value would I have to put here? Okay, so if this is 5, what value would I have to put here to trigger it, the true part of this? At
It has to be 5 or greater.
Yeah, so five would be there. With the second one, to trigger both of the if statements, I'd have to go to 6, right?
Yep.
To trigger. Here, regardless, and this is why if else is so powerful, I only have one value to change. I don't have to change 2 values to trigger the statements. Like there's no functional way I can trigger both to run. So I'm either gonna put in a number to trigger the true, or I'm gonna put in a number to trigger the false. It's one or the other. There's no getting both of them to work, and that's the point here. All right, let's move on. All right, another scenario might be like, really, what if there's more than one option? Okay, so maybe it's like this. Maybe it's like, if money in pocket is $20 or more, I can order pizza. If money in pocket's $50 or more, I can order pizza, cookies, soda, and dessert, whatever, some cookies, whatever, I can order the party pack from Pizza Hut, Else, we're making mac and cheese. If you don't have more than 20 or you don't have more than 50, then you're switching over to mac and cheese. Right? So notice that when we do this, we can actually take an else. So if the first if doesn't catch, then we can ask another if. That's the point here. We can say else, if this statement is true, then do this one. Otherwise, without testing anything, the only thing that's left is that was lovely. So in this case, we're saying the video length's 120. The first statement does not kick in, so you notice that this has no output. The second statement says, is it greater than 500? That's not true either. So ultimately, that was lovely is the one that displays, because 120 is not greater than 500, and it's certainly not less than 5. Right? It says, using else if lets you add another conditional statement, which is only checked if the first one is false. So it doesn't automatically get checked, only if the first one is false. If that one's also false, then it falls down to the next thing that is, and in this case, it's an else. But it is possible, and they're showing that below, that you can have multiple condition sets. So you could have if, else if, else if, else if, et cetera, and catch a bunch of different scenarios. So in here, they have one that's 75,000 long, certainly doesn't hit the first scenario. Is it greater than 50,000? Yes, so that one will output. Is it greater than 500? Well, it is. But here's the point. It never reaches this statement, because once it hits one of the statements that are true, it executes the code between the curly brackets and then jumps out. So if you wanted it to react to this one, right, because it is true that it's greater than 500. So if this statement was changed, so if I change this one to 50,000 and change this one to 500, notice what is happening here. The 500 clicks is true, and then that code executes, and the 50,000 doesn't execute. So it can kind of work against you. So when you're structuring these statements, you have to be careful with the logic of it. There is actually a procedural logic, and then finally the else, because it doesn't have a condition, if none of the other conditions stick, then that one will always execute. All right. Any questions on that? That's pretty clear how that operates?
Yeah, it's pretty clear.
Thank you. Then we also have this concept of compound conditionals. And okay, so they give us a scenario here, so let's read through it. It says, imagine your 5-person band gets a gig and you have 450 pounds of equipment to haul from your van to the stage. you know that each member of the band can carry 50 pounds of gear per trip, but if anyone has to make more than 2 trips, they swear they'll quit on the spot, right? So you do some arithmetic to figure out whether or not the band should accept the gig. All right. So first we have a constant here for band member count. So we got 5 guys. This is the amount they can carry per person. I think they could up that a little bit, but hey, that's just me. And then the maximum trip count is 2 trips to the van. All right. That is an ideal world for sure. We have 450 pounds of gear. And then we have this calculation. So total carrying capacity is equal to the band member count times the weight per person times the trip count, which happens to be 500. So in other words, given this scenario, we can send each guy to the van twice and we can carry a total of 500 pounds of gear. Makes sense, okay? So now we do the conditional. So here's the conditional. If the gear weight is less than the total carrying capacity, so if that's true, then we're going to say rock on, and apparently that's true. It is. 500 is more than 450. Else, everyone quits. Looks like you've got a solo show tonight, right? Now, I can change any of the values up here to fudge that, right? Whether it's the weight per person or the total gear weight. So let's say one of the guys in the band gets like a new speaker cabinet and the weight goes up to 550 and now everybody quits just because of that one speaker cabinet. It's a deal breaker, right? So you can play with those numbers a little bit to see kind of the result. All right, so the scenario obviously leads to you take the gig and one of the pieces of equipment weighed 100 pounds and it was raining when you arrived and nobody wanted to get wet hauling heavy gear. So it looks like your decision is more nuanced, right? So in other words, if rain seems probable, you shouldn't have any gear that's difficult to carry. In summary, you should only take the gig if you can handle all the gear in 2 or fewer trips and it's either unlikely to rain or you don't have any especially bulky gear. All right. And here's the thing, right? This actually is a complex statement. So this is what they're trying to lead you to here is, all right, can you handle all the gear in 2 trips or less? That's the if statement we wrote here, right? So this already determines that. Now we also want to do a secondary check. And when we do the secondary check, we want to make sure it's unlikely to rain or we don't have any gear that's really, excessive, right? Like so you have your bass player's got like a giant bass cabinet or something, right? So let's take a look at the setup data here. They say, let the chance of rain equal 0.5. That's 50%, I believe is what they're shooting for here. And the bulkiest item weight is 60. So they're setting a threshold. Now we already have all the other stuff up top, the band members, the gear weights and all that is already predetermined. So that part still sticks. So if that statement is true, and I want you to look at this really carefully, if that statement is true, we know it is, then we execute the code inside the first set of curly brackets, which run from here to here. And I'm highlighting it on purpose because this curly bracket matches this one. And you guys notice what I do like here in Swift when I click on the one curly bracket, the matching one highlights, right? And that's on purpose, so you know. So in other words, if this resolves to true, which it does, then we will execute all of this code inside, which interestingly is another if statement. So we passed the first test, but now we're going to ask the second one. And we're going to ask if the bulkiest item weight is less than 80, we're going to do the show, right? We're going to go ahead and carry that gear. Otherwise, if the chance of rain is greater than 10%, which it is, by the way, everyone quits. It looks like you've got a solo show, right? Like your band members don't want to play with you. But, and then if neither of these scenarios hit, then everybody quits. So it looks like they have more scenarios for quitting. But does this make sense though? The bulk item weight is less than 80. So that's true. So we rock on. But it's Also true that the chance of rain is greater than 10%, but they're checking this first. So really both statements are true. So only the first one happens. Right? And thankfully it's in that, setup there. It says, but that code is less elegant. Okay, one result is duplicated due to the complex logic expressed by multiple if-else statements. And this is one of these nuances, by the way, when you learn to write these kind of statements, where if you have a bunch of statements that are leading you to the same output, chances are you're asking the logic incorrectly. And that's really kind of a fascinating thought. And it says, in addition, the nested code isn't very clear to read, and any manager that came after you would have a hard time tweaking your algorithm. Of course, adding a few new factors would produce even more tangled code. So what they're saying is if you're asking an if statement, really going to another if statement right away might not be the best way to handle this. It really is kind of very nuanced is a polite way to say it. So it says the solution lies with Boolean operators. The key terms from your complex decision are the words and or, and they did actually highlight and, but they didn't highlight or, right? So it wasn't clear here that this is really what they meant, okay? Now, when we ask these questions and or, there's a little bit of thinking we have to do about this. And this is, one of those concepts that for new programmers can be difficult to wrap your head around, especially when your logic tests are complicated. So for example, when we want to ask the question and in a logical test in a programming language, we use the ampersand as a very common one to do, and usually a pair of them, right? So, so we say false and false. Now, so here's where this gets kind of weird. I can ask a question like the one that they have here about the show. Can you handle all the gear in 2 trips or fewer? We know the answer to that is true. We can do that. We don't have so much that we can't do that. And then we need this whole side of the equation to evaluate to true also in order for the and to stick. But this part of the equation has an or in the middle, and for an or to evaluate to true, only one of the statements needs to be true. They could both be true, but only one of them needs to be true in order for the whole thing to actually negate. So what they have here, even though it sort of works, isn't actually correct, right? But here's kind of the point. When we are looking at a logical test, an and implies that both sides evaluate the same way and preferably to true. Now we have false and false. Of course, the result of that is false, right? If we have true and false, remember the rule for and is both sides have to be true. That's also false, even though one of it's true. With the third version, once again, only one of them is true. The other one is false. So that's still false. But if both are true, it's true and true, then the whole statement is true. So with an and, both sides that are being checked must be true for the whole thing to evaluate to true. So with an or, it's different. With an or, if both are false, well, it's false. But just think of how the terminology goes. If something is true or false, then it is true with an or. We only need one of them to be true. So if the first one's true, it's true. If the second one's true, it's true. If both are true, of course, it's true. And even though it's an or, but we only need one or the other to be true. If it's like, if it's gonna rain, if that's true, or we got too much gear, if that's true, then we're not gonna do it. Now, it could be one or the other, but both of them could be true, right? And it would evaluate to true. So here's the revision of that statement, more accurately stated to match the statement that was listed above. And this is kind kind of a learned thing in programming, once again, to like develop statements like this. So here we say, if the gear weight is less than the total carrying capacity, which we already know that's true, right? That's already established. The other aspect is an and then we evaluate this complex statement, which has an or in it, and two conditional statements. So the first part of it is the chance of rain less than 10%? Well, that's false, right? Because it's 50%, right? Or is the bulkiest item less than 80? Well, the bulkiest item we have is 60, so that part is true. So this statement's true, this one is false. Because it's an or, the whole statement then becomes true. And if I have a true here and a true there, then we rock on. We do we evaluate the true and we rock on. Otherwise, everybody quits. And you can see that there is a nuance here that the previous version is missing with that if statement, right? It still works. I mean, we're still rocking, basically, but it's not as easy to read, and the logic is harder to follow, right? In this scenario, we're kind of testing all three of the scenarios at once, and we really only have two paths of action. So the point really is, if we have two paths of action, let's see if we can combine the conditional statements to direct us to that, as opposed to like doing these weird nested if statements. Not that they wouldn't work, but you will see with experienced programmers, they will more quickly adopt this approach with experience over this approach. Unexperienced programmers will typically do something like this and will still not be exactly right. They're not thinking about and or, right? But those are really important concepts when it comes to this. And this is a really good example, I think, in terms of working out the nuance. All right, I'm going to move on here. All right, let's take a look at this next thing, because we have learned about functions, right? How to name a block of code, give it a name. And we also learned how to pass parameters, right? And also get return results. And I think this is kind of cool, because now we see one of the more practical usages of functions. Now, the functions that we were working with previously, we were either returning an integer value or a string value, right? And you remember, when you declare a function, the return value is indicated like this. So you have that little dash, greater than, and then what the data type is. So whether it's a string or an integer. In this case, we're returning a Boolean. And this is kind of interesting. So the job of this function is then to basically make the determination of true or false for us, and then just feed it somewhere else as a value, saving us the need to write all this like stuff. Okay, so look at how this works then. We have a function basically called band can carry gear, right? We have all of our parameters. So we have the band member count, the gear weight, the bulkiest item, and the chance of rain, right? All the same data we were working with before, but now it's in the form of parameters that are passed to the function. We also throw in these constants. The maximum trip count is still at 2, and the weight per person is still at 50. They're still treating them like constants, like those aren't things that are going to change, right? Then we take that carrying capacity, same calculation we had before, and we know that evaluates to 500, and it still does. Then we have a return statement, and notice what is in the return statement, and this is a real common programming technique. We are taking that same conditional statement from the if statement and writing it in the same format here. We're not saying if, but it still evaluates to true or false, right? And then we're just returning the result. Interestingly, this is evaluating to false. Is there a reason for that? Is this a different result? I'll have you think about that. Is there something here that's different, perhaps, right? Okay, so this approach completely hides the complexity of the decision, and it says the functions that return a Boolean value can be used directly in an if statement like this. So watch what we do. So we can say if, and then instead of writing that complex statement, we just send the values in for evaluation. So we say, if band can carry gear, right? So that's the name of the thing. We send in all our values. The function determines whether it's true or false. It sends the value back. In this case, it's sending back a false. And then looks like everybody quits in this scenario, right? Now, what's nice about this type of an approach, right, is it hides the complexity of the logic inside the function, but it makes the code readable in the if statement on a different kind of level. So it says, if band can carry gear, true or false? Well, if they can, rock on. If they can't, everybody quits, right? And it creates this like simple syntax. Now we still have to send in values. So like if I sent in, like if we have 6 band members, would that change things? No. If I have 9 band members, would that change things? Yeah, I guess so, right? Got plenty of people that carry the gear. What if the chance of rain instead of 5% is 50%? Well, it looks like everybody quits, right? But maybe it's 0.005. Are we rocking on? No, we still have weight restrictions, but that is kind of a different approach, right? But the key takeaway here is that you can have a function that returns a Boolean value that does all the same testing that we would do in an if statement. It just does it kind of internally to this function. And then you have all that logic spelled out here. These are all, conditional statements, the same complex and an or statement that we were using before. The other thing I do want you guys to notice is when you look at like the second part of this, notice how there's parentheses around it. And here's kind of the why to that, just like with math. If I were to omit these parentheses, it would go, is this true? And is this true? And treat this whole statement as an and then take the result of that and compare it to the or, which is not what we want, right? So sometimes you use parentheses to make sure that your or scenario is correctly identified. All right, I think what we're going to do now is let's take a quick little break. We've been going for a good hour. Let's do like 5 minutes and then we'll come back and resume. I will hit the pause here. All righty, we are back from the break and we're moving on to the next page here. And this one talks about the remainder operator. All right, so here's kind of, I like the scenario they have set up here. It says your band hired that extra member and has gone on tour, but there's more trouble. So apparently this guy doesn't like to carry gear either, right? They insist on a bowl of candy in the dressing room every night. If it doesn't divide exactly between all of them, they'll quit. All right. So remember from your first playground that you use the remainder operator to find out if one number divides evenly into another. Can the candy be split evenly among your band members? Check if the remainder is 0. So here's one of those scenarios, by the way, where people are like, when would I ever use the modulus operator? And here's an example, right? So here we have now a new band member count of 6, and now we have 79 pieces of, I assume, M&Ms or whatever it is, Reese's Pieces or whatnot. And so we say if the candy count mod the band member count, as long as the remainder of that division is 0, then we will rock on because the promoter or whatever counted the candy correctly. Otherwise, everybody quits and there's no show. And 6 does not go into 79 evenly, by the way. So everybody quits. All right, so when reading the code, it's not completely clear what's happening. The modulus operator and the double equal sign being equal to 0 distracts from the question that the code is asking. So once again, to make it clearer, you could put the code inside of a function. And you notice like how they're pushing this concept real heavily. And so look at the new function they're creating. On line 18, it says, is the candy amount acceptable? And I want you to even look at how they're naming it, because if you're asking, is the candy amount acceptable, what kind of answer are you looking for? Yes or no, or true or false, right? And so a lot of functions that evaluate to Boolean values of true or false in programming often start with the keyword is, or they're asking a question. And so looking for a Boolean response. And then all of the mathematics that you would use in the if statement to check the condition then just get moved to the function. And the function is then rewritten once again, or excuse me, the if statement is rewritten with a function call in it and the parameters being passed. The beauty of this approach, of course, is, I mean, yes, we have these hard-coded right now, but this approach also kind of allows us flexibility. Does the if statement allow us flexibility? Well, it does actually, right? That also works. But you'll notice that the second approach is actually a little bit more powerful in terms of what's happening. All right, so we're going to move on then to the next page here. And you'll notice that this is where we kind of come to the end of all the concepts that are being presented. But the main points of this particular segment of this unit are making decisions and choosing which code to run based on those decisions adds power to your code. So the point is that sequential step-by-step works great, right? Up to a point, but sometimes you have to consider one path, one fork in the road or the other, or multiple paths in the road or another. A lot of these decisions are based upon asking the right type of questions or comparison statements that evaluate to true or false. True or false, once again, we call those Boolean values, right? So whenever you hear Boolean, it means true and false. And in Swift, you just use all lowercase, the whole word true and the whole word false, and those are keywords in language. Whenever we look at comparison statements, so that would be like when we're like, is X equal to Y, for example, or equivalent to Y. Those statements do evaluate to true or false. We can also use compound statements. And then the other piece that they threw in towards the end there is sometimes taking some of those evaluations, throwing them in a function to make your code read better in the if statement. And there seems to be a propensity of that in Swift. Normally, like when I teach these concepts in a regular programming language, I don't push that piece of it so heavily, but they seem to have a strong preference to that. And they, of course, have an example here. It says, let you want to practice equal true. So if you want to practice, which is true, then you execute, go to the exercises. So let's go to the exercises. All right, so now we'll get to actually try this out. And we have, and I'm trying to remember how I put this into the course shell here. So I'm gonna like pull up Blackboard here just a quick moment. And I think I combined all these exercises. So there's three exercises and they're all combined into one. And I think that, just because of the way that we've kind of proceeded today, I think probably what makes most sense to me is let's just collectively code this. So I'm going to help you kind of complete the homework. And while we're doing it, for those that missed the early part of the lecture, you get a little lecture peppered in there as we're kind of going. Right. All right. So let's take a look at what this one says. It says, come to grips with the if statement by rewriting the following comments in code form. All right, so in other words, they have an A, a B, and a C, and A is 20, B is 30, and C is 20. Now they want us to rewrite these comments as code. So let's see if we can kind of do that. I'll get the first one started, and we'll use the keyword if. That is all lowercase, by the way. No capital I in the keyword if. What they're asking here, it says, if A is equal to C, print A and C are the same. So here we go. So I'm going to take the named constant of A and the named constant of C, and then to check equivalency, here's where we use the two equal signs. Remember, single equal sign is an assignment statement, assigns a value to a constant or a variable, like we see here, right? A double is a logical test or comparison operator asking if A is equivalent to C. And this is really more the traditional way we think of an equal sign. The result of that, of course, is either true or false. So A is either the statement is true or either the statement is false. We can see above that it's true, correct? A is equivalent to C. So let's do the print command and let's just say A and C are the same. And that should output to the screen. There you go. So there's the first. You can unmute whenever you want. I just didn't want that in the recording, that's all. All right, so let's try the second one. It says, the next one says, if A is less than B. All right, let's practice typing that. If A is less than B, then we do our curly brackets. And then we should say print B is ahead of A. That's what they want us to put in there, so that's what we're putting in there. So is that true? Yes, it is. B is greater than A, or the other way to say it is A is less than B, right? It just depends on your perspective. And this is what I was talking about before. Is that a greater than symbol or a less than symbol? Yeah. Technically, that's a less than symbol, by the way. To me, it doesn't really matter what, it's greater than or less than, depending on which side of the thing you're sitting on. That's really what the correct answer is. All right, that one also is true. Let's try the next one. This one says, if B is greater than A, then we want to print A is not winning against B. Okay, so is that true or false? That's true also, right? So B is greater than A. All right, I got one more. No questions on this so far. I assume you guys are okay with this. Is very simplistic, isn't it?
Yeah.
The couple of examples we just had on the previous pages were a little bit more complicated for sure. Right, so let's type this one. If A is less than or equal to, right? So the combo operator to C, then we put our curly brackets, and then we use our print, and we will say A is either losing to or tied with C. Okay. So that one's also true. So all of the statements were actually true here. All right. I think that was a pretty easy exercise. So if you guys want, go ahead and finish this one up and then make sure you do your screenshots. You may as well get that piece of it together. So that would be if statement practice. You can see the output from the console and grab all of that and turn it in. All right, let's move on to the next exercise. All right, so let's see what the scenario is here. It says you'll recall that else statements hold code that's run when the result of an if statement is not true. They can reduce the amount of code needed and they make it clearer what the flow of the program should be. And this is the classic fork in the road. All right, so here we have two constants that are declared. One is the secret word banana, and the other one is guess, which equals apple, right? So here we say, if the secret word is equivalent to guess, print your guess is right. If the secret word is not equal to guess, then we print your guess is wrong. Now, what they're really wanting you to do here is, and remember the very first example we did where they had discrete if statements, and then you discover, oh, I don't have to do two logical tests here, because if the secret word is guess, great. If not, well, it's not. We don't have to really test for that. It just either is or it isn't. So if it is, great. If it's not, well, then we just do an else. So the challenge here is to rewrite this code with an else. Now, you don't have to rewrite these two pieces, but what you should do is probably just copy this, right? So we'll just bring all of that down here. And then instead of using the keyword if and having a secondary logical test, this is implied. That's the whole point. We can simply replace this with the keyword else. And normally the layout kind of looks like this in Swift. Now, where you put those curly brackets, I'm gonna tell you that that's kind of a language dependent kind of thing. Like if I'm working in Java, I would normally do it like this in Java, you know, or in JavaScript for that matter. They like you to do it like this for whatever reason. So, all right. Are we getting the same answer on this?
Yeah.
Right, so the logic is working, but that's a really super easy conversion, right? So this is a super easy assignment if you guys are picking up. The lecture materials were a lot more challenging than the assignments are.
Yeah.
All right.
For some reason, mine's coming up wrong, and I just did exactly what you just did.
You know what, Jomar? Let's put yours up on the screen. Can you share your screen?
Yeah.
And I'm going to record it if you don't mind, because troubleshooting is kind of fun. At least I think. At least I think it's fun.
No, it's fun. It's
No,
interesting.
it's
It makes me.
the best learning experience.
Yes.
No doubt.
Okay. Let me see. It's still disabled.
Oh, I'm sorry.
It's okay.
That allows me to keep control of my class, you see.
The whole two people.
I think you're good. Should be able to,
Okay.
you know. Yeah, all two of you. All right. And I need to move this. I mean, we're all seeing this anyhow, but I want to move it over to my other screen so it records.
Okay.
Bear with me. I'm wrestling with Zoom, basically. All right. Our faces are in there right now. All right. We'll just leave it like that. I hope you guys don't mind your faces in there.
No, not at all.
Always turn off your cameras. So, Jomar, I'm looking down on line 21 here, and you have, if secret word equals guess, print your guess is right. Ah, okay. I'm seeing it. Are you seeing it, Jonathan? What are the problems?
I am, yes.
Yeah. So where's the problem?
So after the else, you have another if statement there. You don't need the if secret word is not guess.
Right.
That you can just delete that up into, you can delete all, pretty much everything of 24 except for the curly brace. Or no, you can delete the curly brace too.
Yeah.
So
Just
the whole
all
term
24
line?
can go. Yeah.
Okay.
And kind of the grand point here is that instead of having these two separate if statements like we have above, these are kind of logical opposites of each other. That's really the point. Meaning that if the secret word is not guess, then it has to be guess, you know, if you catch my meaning. So it's like, it's either correct or it's not. There's no other scenario. So you don't need to ask the question again. By answering the first question, you get the answer to the second.
Okay.
That's really the grand takeaway. All right.
Okay.
Thank you for sharing.
Yeah, no problem.
Trying to find my mouse here on the screen. And I'm going to move Zoom before I share here. All right, here comes desktop 2. All right. All right, so here's a the last little exercise, I think my mouse battery, my regular mouse, smart mouse battery, I think just died.
Oh, great.
The light, yeah, the light must mean the battery's dead. All right, switching to trackpad. Thank God we have that option, right? Kind of getting spoiled with the smart mouse there for a bit. All right, so here's one that's kind of interesting. And it says, on the conditionals page, you learn that code that looks correct can produce the wrong result, right? And that was kind of an interesting little thing to look at. If else statements are tricky to get right when you're first learning about them, and there's two rules to keep in mind. So it's kind of interesting how they put this all into like an assignment, I guess. Multiple if statements appearing sequentially will all get executed. So that was like what we just did before, right? We had an if and an if. If an if-else statement with multiple else if or else clauses, only one will execute. That's a really big difference in the logic of things. So you need to think about your scenarios logically when you're coding. And if it helps you, and this is what I do sometimes, is I'll think about the scenario, the possible outcomes, and I'll make like almost like a little tree branches or whatever, or an outline of like how the stuff should lay out. And then you sometimes just have to think about it, logically. Okay, it says this page has some code samples with errors. You'll observe how they work and then fix them, right? The code segment below converts number grades to letter grades according to the following rules. F's are below 70, C's are between 70 and 79, B's are 80 to 89, and A's are 90 or greater. One real interesting sideline about this is pretty much how we used to grade here at Gateway, like 6, 7, 8 years ago. We didn't have D's, right? Or C minuses for that matter, because if you're in an IT program and you get less than a C, it's functionally an F. And then somebody figured out like, well, but that hurts their financial aid. And it's like, well, yeah, they can get a D and still get their financial aid, I guess, but they have to retake the course, right? So more financial aid pays for that. But yeah, that's not an uncommon thing to see in college, by the way. It's a grading scale like that. All right, so this is the general scenario, the rules. Okay, so we have a grade that's 47, not good, right? So here we got, if the grade is less than 70, you got an F, true, right? If the grade is greater than or equal to 70, you got a C, that's not true. If the grade is greater than or equal to 80, you get a B, also not true. And if the grade is greater than or equal to 90, you get an A. All right. Try to predict what happens as you increase the score. So what will the program print? And one way to do that is to actually try it. So if I put in like a 71, then, well, I got a C. And if I put in 82, I got a C and a B. See like how that's broken? That's not right. And if I have like a 94, well, I got an A, a B, and a C. I'd like the A only, please. Is right. So you can see the flaw with this code. Kind of looks good on paper, and it works for really low numbers, but it does not work for high numbers. So the exercise then is fix the code so that it prints the correct outcome. You might do that by reordering it or using else clauses. So this is going to take a little bit more thinking to get this right. All right, so what we could do here, and there's a second exercise. All right, so we're going to handle that separately, is we're going to make the change right up here to the code directly. What I'd like to do is do this one with you. And I want to kind of talk through it because there's more than one way to do this correctly. Here's the other part of it. So it's a matter of how your brain thinks. Like, for example, the way that they have this code laid out, to me, it makes the predisposition that students are going to score really low, right? Because we have the F's at the top, not the A's at the top. Okay, so is that the way to do it? Maybe. All right, so let's just see if we can alter this. And do we want to make these else's or else ifs? Let's talk about that first.
I want that to be an else if.
Right, because we need to check the condition, right? So if the grade is less than 70, you got an F. Else, the grade is greater than or equal to 70, we got a C. Well, it still worked, but I'm still getting a B and an A.
You gotta change the logic a little bit.
Yeah. What is the change we need to make? So this is kind
It
of
needs to be less than or equal to 79.
okay, because now you're looking up here for the clue, right? So less than or equal to 79. And by the way, when we get all done with this, I'm going to pull up the author's solution so we can take a look at it. Right, all right. So, all right, so if the grade is less than or equal to 79, all right, and that didn't catch, right? Because we're at 94 right now for a grade. Now, what about the next one? That should also be an else if, correct?
Yeah.
All right. And then do we do the same thing here? Do we switch the order?
Yes. We're gonna do the same thing, less than or equal to 89.
All right. And then here's the other question. Do I need to even have an if statement here?
No, you would just do
Or-
else. You got an A.
Yeah, okay. So Jonathan, you're hitting upon what I'm trying to push here. Should I say else if the grade is, would this work?
No, it would just be else print. You got an A, right? Or am I wrong?
No, you're not wrong.
Oh, okay.
The point is, I could ask another else if here, and it's working.
Oh, okay.
You can see the A is already working. But if you've exhausted all the other possibilities, the only other option is an A, right? And this is like where the programmer makes the leap. So that little change I just made, I'm just going to Control Z it, right? So this works because you see the A is still there, or you just get rid of that and just say else because we covered all the other logical conditions, but we did have to change the order of how it's being checked. And in this case, not the order in the values, but the order of the operators, we flipped them. We have to flip to the other end of the scale for it to make sense. So that is one of the fixes. We'll come back and we'll look at the author's solution on that. Let's try the next exercise. I think that's a good fix. All right. Now let's look at the next bit of code here. Okay, so this is, once again, this is related to the band guys, right? So it says, it was written by your somewhat demanding bandmate who explained how they came up with the logic. If a gig is more than 20 miles away, our manager needs to bring something for me to read. If it's less than 5 miles away, tell them I'll leave extra early to exercise and get some steps in. But if it's more than 100 miles away, I'm not really interested in playing. They should find a sub for me. Otherwise, I'm super low maintenance, right? So this is really kind of a goofy thing. All right, convert it into code, right? So we have a gig distance is set for 6 miles. And then we say, if the gig distance is greater than 20, right? I need something to read. Else, if the gig distance is less than 5, I'll meet you there. Or else if, and I shouldn't say or there, else if the gig distance is greater than 100, better find somebody else on bass. Right? So now we know it's the bass player, they're always a problem, right? And then else, you know me, I'm easy, let's hop in the van. All right, so just like whatever, let's just go do it. So here's what they're asking us to do. This says test the code with different distances and see if it's working correctly, and then fix the code. Tell your bandmate they should take a programming course because bass is a dead-end career path. So all right, so let's try a couple different values here. All right, so we have the, and we don't have the thing that's less than 5. So if I say 4, what happens? Does the I'll meet you there work? Yes, I'll meet you there. The gig distance less than 5 does work. How about we set it to 21? It's greater than 21. I need something to read. What if we test the over 100? Let's just set it to 210 miles. That one's not catching, right? See that?
Mhm.
And then, yeah, so the 100 level is to find a sub. And otherwise it should be super low maintenance, but I think we've already put in values that are either greater than or less than all these values. And we're never hitting the last scenario, are we? Right. Okay, so what's the fix for this then? What do we put in? How do we change this?
Well, first we gotta address the over the 100 miles triggering that first. I need something to read. So you put gig distance greater than 100 first.
All
in
right, so you're
case it
saying
is.
move this to the top.
Yes.
All right, let's do that. I'm just going to copy this. I think I copied it. All right, and let's just put that up here at the top. Okay. Then this will have to, we have to add a curly bracket here, so you don't want to forget those curly brackets. Then we'll say else if, right?
Yeah.
Now, does it make sense to check 20 next?
Let me think this through. I would do.
Well, here's my suggestion, by the way, like if you're trying to solve this kind of problem, let's get rid of the code that we copied for one thing.
Yeah.
Let's get rid of that.
Okay.
And now let's put some values in. So if I put in 5,
Yeah.
all right, so that's a hop in the van scenario. If it's 4, which is less than 5, I'll meet you there. That's working. If it's 25 over 20, is that working?
Yeah.
And then if it's 250, which is over 100, is that working?
No.
No, it is working.
Oh.
Yeah. And so, I mean, what's kind of neat here, so I don't know if you guys are catching this, whether we're working counting up or counting down, you can kind of adjust. With the previous example, we changed the order of the signs, but we could have also changed the order of the numbers. That would have been one way to do it. In this scenario, we started with the larger value and worked our way down, and all the scenarios correctly caught here, and we were able to trigger the else at the end also. So it worked. So this is actually a good solution. What I'd like to do with this one is I'd like to take a really quick look at the teaching version of this one. And see what they have for a solution just to compare. And I think that's kind of fun, honestly. So let's go to here. All right, and we'll just do a little side by side. So let's look at the grade one first. All right, I'm not seeing the solution here. So am I missing something? Yeah, I'm not seeing the solution. Okay, I thought the author had a solution in here, but apparently they don't.
Is there a solutions section maybe? Like
No,
answers at the back of the book?
No, usually they just have it right on the slide.
Oh, okay.
Or they have it, if you think of it as a slide, I guess, right? But regardless, I think we have proved that it works. So I'm not sure why that one doesn't really have a solution, not that it's really all that difficult to figure out. But I think we showed that this worked just fine, and we did try different values, right? Didn't we? So if we
Yes.
set a low number, the F works correctly, maybe then they get a 71, and they got a C, then they got a 88, and they got a B, and a 99, and they have an A. Right, so all those work. And then I think we tried all these values too, but let's just reiterate. So we have 2 miles. I'll meet you there, right? 120,000 million miles. I better find somebody else. Let's go like 30 miles. Oops, 33 miles. I need something to read. That's correct. And then maybe 11 miles. And then, you know me, I'm easy. Let's hop in the van. Right. Right. So I think we have a good solution for this. I'm going to pause here for just a moment. This last exercise that's in this playground is an optional one for us. So this is an extra credit one if you want to try to complete it. But I don't know if you guys are aware of this, but like leap years have a pretty complicated formula. You know, I think most of us have this assumption that every 4 years we have a leap year, right? I mean, so that's generally true. So this is how you decide: is the year divisible by 4? Is the year divisible by 100? Is the year divisible by 400? If so, it's a leap year. If not, it is not a leap year. Right. So this is really kind of an interesting formula. If it's not divisible by 100, it's a leap year. If it's not divisible by 4, it is not a leap year. You catching all the terminology here? That's why this one's kind of a hard one, and I don't necessarily force you guys to do it. They have built in, you know, a function here. Is it a leap year? And it has been built into the playground to make it exercise easier. So in other words, they already have the math kind of done for you here. What they're really hoping that you do, and I'm trying to find my mouse, there we go. Complete it so that the rules are followed and all the examples get the correct answers. And what they're suggesting, and this is a really good suggestion, try using the rules as pseudocode by making them into comments, then write the code that goes with each one. So kind of like we did with that first set of if statements. So if you wanted to give this a try, you could do it. And then you could also adjust the function to actually return a Boolean value. And that's really the challenge of this assignment. If you guys complete this, this is extra credit. Remember, there is a teacher solution, so you can, like, you know, in principle, there's a teacher solution. We just saw in the last one that there isn't, but this is something you could also look up to if you wanted to really figure out what the logic is. That is a kind of a complicated formula because this is exactly that one scenario they were talking about, where the if statement's inside the if statement, inside the if statement, and there's a couple of negations in here too, which are the negative or the opposite. So you got to be really careful with how you put it together. So that's why this is a little bit of a challenging one. And who thunk it? I mean, I always thought it was just divide by 4, but apparently that's not the case. So, all right, folks, I'm going to pause the recording here again. All right, so we just completed working on the making decisions playground here, and we're going to move forward now to Unit 2.2, Section E, which is playing with this thing we call the Boogie bot, right? Okay, so I'm going to give you a little heads up on what this is in advance of bringing it up on the screen. It basically is a pre-built app that has a dancing robot with functions that control its actions, and we will manipulate those functions to make it dance differently. That's kind of the grand plan here. All right, so I'm going to go ahead and bring this up. And of course, it opens on the wrong screen. Always does that, right? And so here comes the app. Okay, so this is the first tab here. Now, because this does have some graphical stuff in it, this may be more prone, by the way, to make your Xcode freeze up or crash or choke, by the way, depending on what you're doing in here. All right, so let's talk about the Boogie bot here. And this is one of those where it's like, it's goofy, but it's also kind of fun. So like, roll with it if you would. It says, in this playground, you get to know the Boogie bot. You'll use your knowledge of functions to make it dance by calling existing functions. Then you will create your own functions to change the dance routines. Finally, you're going to add a text title, sign your work, and save it as an animated version of the static image below. So right now, this is what your Boogie bot will look like. It'll be this figure dancing, basically, for as exciting as that is. All right, so let's move on to the next thing here. So now you can already see in this live view, and this is kind of an interesting feature of the playgrounds also, because so far, we've been doing stuff and we've mostly looked at console output. If you guys remember, there were a couple of visualization things really early on, but we kind of glossed over them. This one is a little bit more pronounced, and you can see all the maneuvers that the Boogie bot is making there. All right. So basically what they're saying is the live views are a feature that let you see instant updates to the code you're changing without having, to like do additional work to like launch it or run it in a simulator of some sort, basically. This does have some behind the scenes stuff going on. So that's what they're saying in the second paragraph. So in other words, there's code that's written attached to this that we're not seeing. What we're going to see is basically the names of the functions that are controlling the robot, and then the true black box fashion of a function. You don't necessarily always get to see inside of that function to see what makes it tick. Like the print command's a great example. Like, why does that work the way it does? We don't know. We don't care, but it puts stuff on the screen. Same thing here. All right, so it says, before you get started, make sure your playground is set up to work with live views. The following line of code sets up Boogie bot and makes it dance. So if you're seeing the robot dance already in this view, that's working. Is yours working?
Yeah.
Yes.
So I see nodding. That's wonderful. Every once in a while, we will see this not work. And when I was doing my training on this, we had at least a couple people that, for whatever reason, they must have hit something, in their environment that prevented it from running. Right. If you don't actually see anything there, then you go up to the editor and you toggle the live view on. That's where it's located. See that? So that's just up in the menu. All right, let's go ahead and now get the Boogie bot to do some stuff. All right. So I'm going up to the top here, and it says, to set up Boogie bot to get ready to dance, use this line of code. So the function start bot launches the bot and runs it. Okay. Then you're going to realize that the Boogie bot can do these moves. Left arm up, down, right arm up and down, same with the legs, up and down. It can shake it to the left, shake it to the right, shake it in the center. It can jump up, jump down. It can fabulize and defabulize. And I'm not really sure what those do. But all the other ones are pretty clear from just how they're named. And that's kind of the point of this. The first move changes the Boogie bot into fabulous new colors. The second changes the Boogie bot back to a dull robot gray. So in other words, that's what fabulize and defabulize do. So like if you fabulize, it makes it colorful. If you defabulize, it makes it not colorful. Right, so that's.
Oh, you're muted. Or you crashed.
I think I probably locked up on Zoom. Maybe the was a bandwidth problem, because I didn't have any hiccups here on my end.
Yeah, I'm not seeing any hiccups on my end either.
Okay,
Oh,
that's
might
good.
be my end.
All right. Once it says here, you tell the Boogie bot to move like this, right? And once it gets to the end of the routine, it will stop. And then you can use the editor execute playground to see the moves again. Changing the routine itself will start things over. Okay. So here's the experiment. Rearrange the lines of code above to remix the dance routine, and it will perform the moves in the order they appear in the playground. And what happens if you fabulize or defabulize in the middle of a dance routine? And where do all these functions come from is the other question. We'll figure that out. But let's go up to editor and then find execute on this screen here. Do you guys see it anywhere?
I don't see it.
Yeah, I don't see it either. This is great to record into a video as well, right? All right, here's what I'm going to do. This is
Under debug.
Yeah, maybe they moved it. Yeah, no, I don't see that. I'm going to go to the previous page, right, where it's working, right? And then we go to here. Okay, so there it goes, right? So there it is. So once we land on the page, it does it. So there must be like a refresh or something, and then it stops. All right. If you want to make this run again, so it did all these maneuvers super fast. I don't know if you've caught that. And so maybe that's, I'm trying to see, like, I don't even see an execute command here. But I'm going to hit stop playground, and then I'm going to hit the run button down here, and there it goes. All right, so what they want you to do is change this, right? So they do fabulize like 4 times. Okay, what if we just did it once? And then, you know, we're doing all this like stuff, but we can change the order of it. So I'm going to, for example, fabulize, shake it left and right. I think we already did that. Arms went up, 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 down, down. And you know what? Here, let's just change the order of how it does it and see if it actually works. Okay. You guys, right, so it's like little tweaks. So what I would suggest is that you try just changing it a little bit to see, you know, kind of what it does. And you see it goes really fast, right? So like the timers on these are really short, so it's really easy to change it. Now, all right, so let's talk about this word API, right? And this is a word you hear in programming a lot, and a lot of times people just don't understand what this acronym means. But generally, what it refers to is, we call this an application programming interface. And what it really is a way of saying, it's kind of like the steering wheel in your car is your application programming interface for controlling which direction you're going, right? You don't know what all the mechanisms are, all the parts and pieces and power steering or manual or whatever it is, but you know what the wheel does when you turn it, right? And so the API is kind of like the steering wheel relative to the steering system on a car. It doesn't matter what's going on under the hood or under the car. All right. So basically, an API is a specific set of functionality that a software developer can use to accomplish a task. In this case, the BoogieBot API is making a software robot dance. And so we have to issue these various commands. All right, so we talked about all these various commands already. We played with some of them. But you notice how they have a start bot command, right? Also. All right. Now, the funny thing about this is we do have APIs that are pre-built. And what they're really trying to show us here is, yeah, we could just take all those commands and like in a sequential program, list all the commands. And sometimes we might want it to like basically a series of steps again and again and again. And as soon as you start repeating yourself, then you start to recognize, well, Well, I could put this in a function and then just call my own function to make it run. And that's what they're doing here. So do the disco is left arm up, shake it right, left arm down, shake it center. Okay, so this one doesn't execute here, but it says change the do to disco function into a mirror image. So anything done left becomes right and anything right becomes left, right? And so what they're trying to make the point of is you would have to come in here in this function and change it. So wherever it says left, type right. Wherever it says right, type left. Make sure you're good with the case, by the way. And center is going to be center either way, right? But their point is we've changed these lines in the function so that when we call do the disco, I don't have to change it 2 more times in these other functions. We just keep calling the function over and over again. And you know what? We can, just by adding the line of code there, right? We saw it change. Now you can Command Z all the stuff that you did, switch it back to left, and then watch it. Now do it with the left arm. So that was super, super fun, right? We are also going to do this little piece here, and they have other little functions that are built in. So one is the start bot, but then we can also add a title and a subtitle. You see where they'll sit on the screen. So let's just go ahead and change this. And I'm going to change mine to Robo. I'll just put my initials in there. And so hopefully you can get your titles in there. This is really a hard one, right? So put in names that are good. I am stealing Robo Boogie though from the Flight of the Conchords. If you guys have ever seen that TV show,
Yeah.
Great show. I think it's from their first episode too. All right. So now we're going to move to the next screen. And here's what they want us to do. All right, so besides watching the BoogieBot moves in the live view, you can save an animated GIF of your work, so it's easy to share with your friends. Oh boy, right? You guys are posting this on Facebook tonight, I'm sure. To do this, add start recording right after you start your bot. So we're going to say start bot, start recording, and then add your routine below. So you're going to have to come up with your own title, subtitle, and then series of maneuvers here, right? When you have all that done, we're going to go ahead and execute the playground, and we already know there's no execute button up there, so we're gonna we'll just basically stop and start it, right? And actually, as you're writing code in here, it's going to change stuff anyhow, and then we will save our output basically. So I'm gonna like change the bot title again, and I'm gonna call mine like I did before, Robo Boogie. And the binary solo is what I'm calling it. And then make sure that you guys come in here and switch up some of this stuff. Like you might do some things, for example, like if you want to write functions for this stuff, go ahead and do it. You know, if you don't want to do that, you don't have to. But I'm thinking that I'm going to create a function here so you guys can do this. I'm just going to call mine arms. And I'm going to make it raise the arms and lower the arms in that function. And then I'm going to get rid of these two. And then I'm just going to replace it with, oh, we forgot the parentheses here, right? So I'm going to say arms, and I'll do arms again. And then let's write another function, and we'll call it legs. And then I'll do the leg maneuvers inside there. And maybe the better way to do this, frankly, is I'll take all of my function calls and put them down here. And you see, as I'm changing this, how the animation tries to keep up. And so I'm doing 2 arms, 2 legs. We'll do legs, legs. I think I'm gonna get rid of this. And then I think I'm gonna create another function, maybe just called shake it. Sounds like a good plan. And so let's put that here. And hopefully they don't have a function called that already. And I'm just going to take the 3 shake maneuvers, oops, and put them all in there. Right, and then I'm going to maybe switch it up a couple of times. Maybe I'll put the shake it in the middle here, and then we'll shake it again, right? And then let's create one more function called jump. And then I'm going to take these jump actions here and put those inside of that. So I'm going to jump up and jump down. But you know what? I'm going to do it twice, right, in one function. And then I am going to leave the fabulize and defabulize, but then I'm going to I'm going to really like switch this up. I'm going to go like this: arms, jump, arms, shake it, legs, jump, legs, shake it. How's that, right? And then maybe I will just jump, jump, and shake it one more time. Right? You see kind of like the pattern of this. And then of course we have our fabulize and defabulize to start it all out. And there is the title and the subtitle there and the recording are all kind of built in, right? So if you want to try to run that again, one simple way to do that is just change your code a little bit and then it just relaunches, right? You guys notice that? So is it doing it the way you anticipate? Hopefully, right?
Mm-hmm.
And now you notice how they have a save button here? I'm going to go ahead and hit that save button. And notice it comes out as a GIF. I'm just going to drop it on my desktop. And somewhere on my desktop, I guess I'll just bring up Finder here. Let's just do a new Finder window. And let's go to the desktop. And there's my Boogie bot. And then I'm just going to go ahead and launch that. And of course, once again, comes up screen 1. And then here are all the various states of the animation for whatever reason. So when you open it up in the Mac OS, all those are recorded as separate little things that are part of the animated GIF. I think if you want to see this properly execute, one way that you can do it is you can open up a tab in your browser and then drag the GIF in there. That's a place where oh, there you go. Okay. So this is the preview tool, right, in Mac. And that is very exciting. Now, here's what I'd like you guys to do when you turn it in, because this is an assignment, by the way, is show me how you created functions and how you use them. So screenshot that code. And then if you can also turn in the GIF, I'm really curious if Blackboard will render it or not. You know, like will it actually show it as animated GIF? I guess we'll find out. So that's how I did mine. And I'm not sure how I got it to preview mode. That's what I'm looking at here. That's a regular open. Let's try preview. That's preview. So how do you see the?
I think maybe you clicked the icon.
Okay, well, it does work in the browser, right? So either way, right. So now this is really goofy, right? And who knows what code they use to create it. This is the grand takeaway. But knowing what the commands are to control it, you can figure out pretty quickly how to make it do stuff that's kind of interesting. This is not very hard coding in the background, but whenever objects are moving on the screen, it does require a certain type of code that we haven't really quite learned yet here. All right, I'm gonna say goodbye to the Boogie bot, right? Because that was one of the things that we were working on then. And then I want to go to the data visualization playground. And I think this is where we're going to end things up today. So like the app build is going to come next week, by the way, right? I think we're probably just going to run out of time for it. Maybe we'll get started. We'll see. I did want to look at this. This is an optional piece, by the way. So this is not required that you do this work, but I still think it's interesting, especially if you're a person who's in maybe either the web program, the software program, or the data program here at Gateway, where we do often create visualizations of data in programming. So I'm going to go ahead and bring up this visualization here, or this unit on visualization. And I need to go back to the first tab on this. And basically what this is about, and you might find this marginally useful for yourself, maybe not useful at all, but kind of along the same thoughts of like how we control the Boogie bot, you can control actually more complicated structures inside of programs with APIs. One such thing is creating data visualizations. And often when you guys learn how to code, right? Like if you are in the data program here at Gateway and you learn how to manipulate data and sort data and analyze data, and then ultimately it leads you to creating charts, graphs, and plots and stuff for people who don't know how to look at numbers and figure them out. Because visuals can speak a lot more clearly than sometimes words and numbers can, right? And so what this helps you do is to build visualizations that are really common. And they start with pie charts. And so what they're going to do here, and once again, we kind of have this live view. At first, they talk about what a pie chart is, and I don't really want to go too deep into that. But basically, when you look at a pie chart, the entirety of the circle represents 100% of what's possible in whatever scenario you're working in. So if I'm trying to represent a data point on the chart that represents half the data, it will occupy half the circle, right? And it's a mathematical pie slice that we're kind of doing. So in order to build this particular visualization, they have a couple of pre-built functions that basically, like this one here, where we add a wedge with a particular color. So you can, like, if you want to represent something in a certain color, you can choose what that color is. And then we also send in, and this is kind of how these API calls work, right? So this is the name of the API is add a wedge or part of the pie. We want to know what proportion that wedge should be and what color it should be. So that doesn't happen automatically. The other thing that's kind of on the programmer here, if you're not picking up on this, is it's up to you to make the pie slices add up to 100, right? It's not automatically going to just reach that. All right, here's some of the colors that you can choose from, right? And here's the experiment, all right? So first they have a call that just creates the pie chart, and then they have all the add wedges, and they have different percentages here. So there's 15, 35, 40, and 10. Does that add up to 100? You guys are trying to do the math really quick. Yes, it does. It does add up to 100. So that's one of the things. And really, because they're decimal values, adds up to 1 is really what it is, right? And then you just specify the color. So what if you wanted, for example, I could take this slice, the red slice, and make it 25%. Now, it's not going to know what to do with this. See, it's kind of breaking because now we're going over. Then this one could drop down to 25%. So my red and yellow should now be the same size. And this is kind of the experiment. Maybe one of these drops down to 5%, right? Which leaves us a gap that we could add another wedge. And so far we have 30, 70, 80%. So we need 0.2 here to fill it out evenly. And then we need to choose a color from that list up above. Let's go with dot magenta. Right. Oops, totally typed in the wrong spot, but that's okay. Dot magenta. All right, let's see that propagate, and you see how that filled the space. And once again, we're at 100%. So that's kind of the thing. Now, if you guys are doing these, or you guys are following along and doing this with me and making alterations, screenshot your change to the code and screenshot the graphic, right? Turn it in, grab that extra credit is kind of my advice, right? Why not, right? All right, let's move on to the next example.
I would say though, I don't see the pie on my screen, but everything else was popping up though.
Oh, okay. So like you are not getting it to resolve or execute. You know, what I would suggest is make sure that all your code is correct. Or if you click here in the coding area and just type a blank line, sometimes that forces it to relaunch. If that doesn't do it, and you know, see up here in my toolbar how the circle is spinning?
Yeah.
Yeah, that means it's trying to run it.
Yep, there it is.
Okay. Yeah, and it looks like I did something wrong here, and I'm not really quite sure what, because I do have an error. It says, almost like I put in a breakpoint. I'm not really sure why I didn't put in a breakpoint, but whatever. All right, but that's how it operates, basically. Okay, now the error went away. Okay, go figure. No idea why. All right, let's go to the next slide. With this next one, what they're doing is this pie chart API also has built into it the capability of putting in your own key to the pie chart. Now, what I would suggest that you do if you want to try an experiment here is maybe change one of these, like the red one. We'll make it 30% instead of 35. We'll add a wedge. We'll make that 0.05 to get us up to 100%, and then the color will be, oh, I don't know, orange. Dot orange. Not sure what happened there. There we go. All right. Now, if we're adding it there, then we also have to add it to the key. So that's what this exercise is all about, you know. So we're going to add a key item with the word oranges, and the color is dot. Interesting how it's not auto typing that one. I'm not really sure why. And there it is with the new key item. So you got that one. right, let's move on to the next one. Now what they're suggesting, right? Okay, and here's you know, what they want you to do at this point is come up with another pie chart, right? So this is one I'm going to leave for you guys to do. I think the examples are pretty clear. So come up with something here to work towards earning those points. So like you got to play with one. Now all you have to do basically is come up with your own pie slices with your own color codes and your own key, right? And be
Okay.
creative. You know, like if you can't think of something good, you could like Google a pie chart of some information and just copy it and try to create it with code. All right, that would be my suggestion. Now, I'm not going to do that process. You know, that's the extra credit part, right? So this is how you're getting part of that extra credit. Let's move on to the next one. Another type of visualization is bar charts. Now, unlike the pie charts, bar charts are pretty helpful because I like these a lot because they show relative value. When you look at a pie chart, I mean, it kind of, you know, does that, but I think a bar chart's more effective because it does it with height. And the other thing is we're not necessarily concerned about filling a circle 100%, right? It's kind of, not that that doesn't apply, but it's irrelevant, you know, because if I add another value, I don't have to worry about it adding up to 100 is the thing. Some of the functions that you're going to use here are the width length and the color. So adding a bar with a certain length and a certain color, and that's going to be numeric and then a color chart very much. Or if you want to compare that back to the previous one where we did it with proportion, but this is with length. So what they're doing, for example, here is they're just using straight numbers, so straight integers here. So like one is 1, the others are 5, 9, and 3, and that's how you get these various things. Now the challenge, of course, would be let's add one. So let's add a bar with, we'll come up with a number somewhere in between, and then come up with a color like, let's go with orange, just to kind of throw it in there. And it should, after a short period of time, propagate. It takes a little while, right? And it's still giving me an error message here, but it did work. All right, so there's your example of switching it. I'm going to move on. The next thing that they do is then they add a label. And notice how the labels are just a very simple thing. So what I'm going to do once again is I'm going to do another bar here just to practice this concept, basically. That's not what I wanted to do. We just wanted to add bar with length, I don't know, 45. And the color, we'll stick with orange. That's kind of our de facto at this point. So now the bar should appear. It is still giving me an error, and I don't like it, by the way. What did I do wrong here? Okay, so it just took a second is what it was. And now let's add a label. So add our label, and the string will be oranges. That label should now appear underneath. Right. Pretty simple, right? Once again, we are using an API. So the big takeaway here, and you guys might see this maybe depending on what program you're in, right? So this is program dependent. But like if you are in either the web program or the data program in the advanced classes, you know, so once you get past that first Python course, we do a lot of visualizations like this with Python or with R. And Python in particular has a lot of these libraries built in. Swift apparently does too, right? So it has those capabilities. And once again, I don't need to know how those tools work, but I do know how to utilize them, you know, drive the car with the steering wheel is the example again. So on this page, same challenge, you will create your own bar chart, right? And so you can go ahead, you know, and, you know, they suggest you can find a data set, you know, like maybe you can figure out like, find the NFC North and how many touchdowns have been scored by each team and make a bar chart of it, for example. That would be a thing. So I'll let you guys work on that. The next topic is plots, and plots are another way to represent data, and this is really actually a pretty useful tool, because when we plot data, we use an XY coordinate system, right? This is the same, Cartesian coordinate system that we use that you learned in mathematics and geometry. We're looking at the top right quadrant, right? So all the values are positive here, X's and Y's, very common. And basically these are for things that you plot where you have two values attached to one data point. So in other words, there's two different things that determine, so like how far over on X and how far up on Y you're going. So X and Y are part of each data set. And then there's also a color, I guess, if you wish. And what they're saying here, and you notice they're making all their points black for one thing, but notice how they do that. They just say add a point at, they declare an X, they declare a Y, and they declare a color. Now, what I'm going to suggest is you add a point or two. So just copy their terminology, at, point, at. And I'm just going to, throw some numbers in here. And I'm not really like necessarily, I hope I'm not overlapping any, I might not be, but I am going to suggest that you color it a different color so it's easy to see on the plot. So now I can see my red dot on the chart there at position 6 for X and 5 for Y. So that's an example of how you do a plot. Now, interestingly, if you can imagine these scenarios, right? Like if you have data that was held in a spreadsheet or a database or a text file, for example, or a data feed from a website, and you could read it into a data structure and then have your code read the data structure and drop it into these spots as variables, and then have it create a chart. And think of the possibility here. You could issue a command that runs a program, reads in a file, extracts the data, and feeds it into a plot. Pretty powerful stuff, actually, very powerful. Of course, you can say in your head, Excel does that. Yes, it does. But there's much more of a need these days for people doing it with code, both to get it on, inside of apps or to get it up on like screens for websites, for example. All of this stuff is good. So the other thing that they're doing here is they're setting some parameters and they're changing, notice the XY coordinate system, so actually dips down into the negative, and they're putting in some negative values. That's the only change here, really. All right, so that's not really that big of a thing. Then the next thing they want you to do, finally, is create your own plot. And once again, you can look for data if you wish, or you can just like put in a bunch of random stuff, whatever. It doesn't really matter, just as long as you get the practice of doing it, right? And that would be your extra credit. All right. So that wraps up the data visualizations. And I'm just going to look here really quick at my Finder, and that basically completes all this play with programs area of algorithms. We are going to move into doing an app build, but I think, I'll tell you what, I know that at least one of you needs to go. Maybe we'll get started here, maybe not, but we have to start with a playground before we go to the app build. So let me just pause the recording here for a second. Because All right, so we managed to get through all of the algorithm stuff here. So we've got through all of these sections, A through F. When we come back next time, we're going to work first on the playground for the question bot app, and then we'll do the app build. And what I was just telling the guys is this is kind of a two-phase process. So the app build is more of the graphical part of it, but we like to have the logic for how the question bot answers questions pre-built in code, so that when we go to the graphical part, we can just drop it in and it works. right? And that's going to be kind of a combination. It's a little bit higher level than what we did last time, where we just put graphics on the screen. This will actually have an app that has some interactivity to it. So that should be a lot of fun. All right, this video ends here, and I will see you guys next week.